Hi, I'm Chris, and we're taking a look at this pre-calculus problem. This is from a worksheet in review for a practice test from one of my students. And the question gives us three coordinates, A, B, and C. And right now they want to know what is the angle measure at vertex B of this triangle. So that's what we're looking for. So the easiest thing to do is to see if we can plot these points to have an idea what this triangle is going to look like. So let's go ahead and start with that. If we make an x and y axis and we plot each of these points, we have 3, 1. So that'll be point A. We have negative 4, 3. That'll be point B. And we have negative 4, negative 2. That'll be point C. So we have A, B, and C. And our triangle will look something like this. Now, in order to find this angle, this is where we'll put our question mark. This is the angle we're trying to locate or trying to find the value of. We need to use law of cosines, and to figure out law of cosines, we need to know the length of each side of our triangle. So for this, it means we're going to use distance formula, and we're going to have to apply distance formula a couple times in order to come up with the right calculation. Now, one thing I do want to point out is that if you notice, two of these coordinates, B and C, actually have the same x value. It's only the y value that changes. So we're going to save ourselves a little bit of work right off the bat, and we're going to just go ahead and count off those units. From B to C, if you go from positive 3 down to negative 2 along your y, that's a total of 5 units. So we know that this side of the triangle is 5. We don't have to really plug in a complex distance formula or deal with square roots to solve that one. But for the others, for the distance between A, B, let's start with that one. So distance formula is going to be the square root of the difference in your x's. That would be 3 minus a negative 4 quantity squared, plus the difference in your y's. That would be 1 minus 3 quantity squared. And for this, it doesn't matter which one you determine to be x1, y1, or x2, y2, because since each value is squared inside the square root, then when you go to apply your distance formula, squaring each one will make it come out the same way either way. So it doesn't matter which one you put first or second on those. Don't worry too much about that with distance formula. Simplify this a little bit. 3 minus a negative 4 is 3 plus 4, which is 7. 7 squared is 49. 1 minus 3 is negative 2 squared is 4. So we have 49 plus 4. So the distance that we get will be square root of 53. And for right now, we can go ahead and leave that in square root terms. You'll see why when we apply it to the law of cosines. So this is radical 53 for this piece of our triangle for the side AB. And then for this side over here, AC, we're going to use that same formula, and we're going to just take those different coordinates. So for that distance, we're looking at the square root of 3 minus a negative 4 again, quantity squared, plus, and then 1 minus a negative 2, quantity squared. This 3 minus negative 4, as we said previously, it's the same as saying 3 plus 4, which is 7, and 7 squared is 49. Here, 1 minus a negative 2 is the same as saying 1 plus 2. Make sure you're careful about that with the negatives. Minus a negative is plus. So that would be 3 squared is 9, and this will simplify to the square root of 58. So we can put square root of 58 as our value for side AC. Now that we have all three sides, I'm going to switch colors because that's sort of like the first part of our problem. We have to find those three values to start with. Now we can plug that into law of cosines in order to calculate the value of the measure at angle B. And in order to do that, we want to start with this side, which is going to be square root of 58. So actually, let me write it up here for the law of cosines, the generic form, and then we'll plug in the values down here. So you're going to have b squared equals a squared plus c squared minus 2ac times the cosine of angle B. And so in order to plug in these numeric values, we're going to have root 58 squared equals And it doesn't matter which one you associate with A and C on this in terms of how the math will end up, but typically speaking, in any sort of geometry or pre-calc type of situation when you're dealing with triangles, the capital letter represents the vertex, and then the lowercase version of that letter represents the corresponding opposite side. So we would call this one A, we would call this one B, and we would call this side over here little c. So we're going to plug in 5 in place of A, and we're going to plug in root 53 in place of c. So we're going to have 5 squared plus root 53 squared minus 2 times 5 times root 53 cosine b. And to go ahead and simplify this, here's why we want to go ahead and leave everything as a root until later on in the problem. A lot of times students start working with decimals a little too early, but with a lot of calculations that you have, if you end up squaring something in a calculation, especially when dealing with triangles, things like Pythagorean theorem or distance formula have squared values, and a lot of times what you'll notice is the root will cancel out. So it'll actually make your math a lot easier to not worry about finding that decimal version of the root. You might have calculated the square root of 58 to be 7 point something 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 and written that out, but if you leave it as root 58, then look what happens here. Root 58 squared is just going to be 58 equals 25 plus 53 minus 10 root 53 cosine b. When we combine like terms here and subtract, that'll be 78. 58 minus 78 is negative 20. So negative 20 equals negative 10 square root 53 cosine b. And when we divide by negative 10 root 53, that'll simplify to 2 over root 53 equals cosine b. And when you take the inverse cosine of 2 over root 53, the value that you get for angle B will be 74.05 degrees with a little bit of rounding. Now for that part of it, for the pre-calc part of it, I want to make sure that you guys know how to go through and do the problem. For the algebraic manipulation part of it, if you have a little bit of trouble with that, then please feel free to watch our other videos. But that's more of something that you want to master in Algebra 1, Algebra 2. Once you're working on the pre-calc material, the algebraic manipulation and solving of the variable should be something that you're comfortable with by this point. For more, please feel free to watch our other videos, and thanks for watching.